welcome back to Dr. Ray class. Let's see how we can solve this problem of motion. It's a constant question that comes mostly in WAEC, NECO, and JAMB as well. A train accelerates uniformly from rest for 20 seconds until it attained maximum velocity. The uniform acceleration attained was 1.5 meters per second squared. It maintained the same velocity for another 30 seconds. It then decelerates uniformly for another 50 seconds. It comes to rest. It then decelerates uniformly, for another 50 seconds before it comes to rest. Here we're asked to calculate the maximum velocity attained, retardation, average velocity of the train, and total distance covered by the train during constant velocity. Now, I always encourage learners to first draw the velocity time graph. It will give you a better picture of what is happening and help you to easily make the calculations. And if you follow it very well and learn how to arrange the time schedule given in the question, because that's another area learners make mistakes, it's going to be very easy for you to solve. Now let's start and do it together. Don't mind my lines. Velocity time graph means the slope of the graph will give you acceleration. So I have my velocity on the vertical axis and time on the horizontal axis. Now, how do you put in these values you see in the question? They say the train started from rest. Here is rest, the beginning point. Time started here, 0 increasing. Velocity started from here, 0 increasing. So here is a rest. For the train to accelerate, that means the speed, the velocity will be increasing as time increases. This line is the line that tells this train is accelerating because velocity is increasing while time increases. And we're told that it's uniformly accelerated for 20 seconds. So go to the time axis to where you draw this line and stop. That tells you how long the train accelerated, 20 seconds. Let's say when it was accelerating, it attained a value of 1.5 meters per second. You don't need to put that value in your graph because this is velocity time graph, not acceleration. The next thing you need to check, it maintained the same velocity. What is the same velocity? That maximum velocity, this value it attained. It kept it without changing it for extra 30 seconds. So the speed of velocity will remain the same. Let's say it stops here to remain the same. But we're told that from when it attained it to when it maintained it was extra 30 seconds. What does that mean? The first time it accelerated 20, another 30 seconds to remain on the same velocity. This place has to be 50. That means 30 plus this 20 it has initially attained. Now what happened next? From here, it then decelerates uniformly. To decelerate means for the speed of velocity to reduce as time increases. Don't mind my lines. So this is the line of deceleration. Now from where it attained this maximum velocity until it started decelerating, it took extra 50 seconds. What does it mean? Extra 50 means on top this 50, add another 50. That means the time here has to be 100. Now you've gotten the right values in the right places. One of the things I encourage learners is just label this graph in a way. All these points, put letters. It will help you to describe what you are going to do next. The first question says calculate the maximum velocity attained. What is the maximum velocity? Velocity here was 0. As this line goes up, velocity keeps increasing until a value of velocity here, maximum. We don't know. That's what we're asked to find. Always remember the equations of motion. V u plus at s equal to ut plus half at squared. V squared equal to u squared plus 2as. And finally s equal to u plus v over 2 multiplied by t. Now, maximum velocity. You look at the question given. Acceleration A was 1.5 meters